next, we're going to be talking to Tim Smithies. Tim is with the Lero Research Centre, and he's an IRC-funded PhD researcher at the University of Limerick. He works in the Esports Science Research Lab, and he's interested in how esports athletes sleep and how sleep loss may hinder their esports performance. And as someone who's played a lot of video games, I really understand how sleep loss is definitely something that can affect these guys. More so, Tim brings his research from esports also to look at the negative effect of lack of sleep on cognitive performance more generally. So, Tim, if you're ready to go, I'll hand it over to you.
Sure, thank you very much. Let me just share my screen very quickly. Cool. Okay, great. Yeah, thank you for the introduction. As you said, my name's Tim. I'm doing my research at the Esports Science Research Lab, which is situated in Lero. I'm also funded by the Irish Research Council on an employment scheme with Logitech as the employment partner. And you mentioned quite a bit of esports there. I will tie that into I will tie, I guess, what I'm going to talk about today to esports at the end. But what I'm going to talk about is a review that we actually we wrote in the lab and recently published, and the idea around it and the kind of topic that I'm going to talk on is the idea of elite performing individuals, sleep restriction, and how exactly they're affected by sleep restriction. So the last 50 years or so of sleep research has demonstrated that losing sleep mostly leads to negative consequences for human physiology. And some of the more pronounced effects are on our cognitive performance, so our attention, our memory, our thinking. Another prominent finding is that those tasks that we find most easy or most rudimentary are actually those that tend to be the most affected by sleep loss. And I'm going to show two graphs just here. Without going into too much detail, this was a study that was performed in 1997. And what they did is they actually equated the performance effects of sleep loss to the performance effects of drinking alcohol. And what this study reported was that staying awake for 24 hours consecutively or a full day was the equivalent of a 0.1 BAC, so about having 1.5 to 2 pints, 2 pints of beer. As an important last point, this was in this particular study. This is what we would call total sleep deprivation, which is just simply not getting any sleep at all. There's also sleep restriction, or SR, and which refers to one or many nights of simply not getting enough sleep. And there's an important distinction to make here because they both appear to affect human physiology very differently. So when we talk about elite performers, especially from a sleep research perspective, there are three key criteria. So firstly, their occupation has critical or safety critical demands. So what I mean by that is that they have to perform tasks that have high stakes. Secondly, these particular tasks are highly cognitively demanding and require a level of kind of elite performance. So there's individuals, or these individuals demonstrate cognitive expertise. And lastly, they have a high likelihood of experiencing sleep restriction compared to the general population. And so examples of these kind of people could be sports people, pilots, air traffic controllers, process operators, surgeons, and military or medical personnel, and also military, active military as well. And so what we were interested in particular, or what we wanted to do is we wanted to kind of scour the current scientific literature and see what it had to say on how the performance of these individuals in particular was affected by sleep restriction. So we did a thorough search looking exactly for this. And these here were three of the key criteria for the search that we did. In terms of performance outcomes, we actually divided them into three groups. So the first group being what we call low salience tests or low salience tasks. And these are the kind of simple, simple kind of rudimentary, boring type tasks. An example of a standardized low salience test would be just a simple reaction time test. And if I was to think of a real life application, this could be a lot of the work of a lifeguard, which mainly requires just the maintenance of vigilance over a long period of time. The next category we called high salient stable. Now, this category involves tasks that are much more complex and than the low salience. However, the key part is they don't require what we call cognitive flexibility. Now, what do we mean by cognitive flexibility? So basically, these tasks don't require either an adaptation to a changing task dynamic or switching between many task dynamics. So basically, while it's more complex, the rules never change within the tasks that they have to do. And so kind of the participant or the person that's doing the test or the task shouldn't be surprised by anything. They shouldn't have to adapt to anything. An example of this in kind of a test setting would be what we call a logical reasoning test. And in a real world setting, I guess you could think of performance on a defined preset task on a surgery simulator as being HSS. And then the last category is what we call high salience flexible. And so these tasks obviously do require this cognitive flexibility. A real world example of this would be a military exercise in which the colors that represent who are friendlies and who are enemies are changed at a random point throughout the exercise, kind of without the people's knowledge, and they have to adapt through feedback. Okay, so what did we find? Well, firstly, and as expected, sorry, excuse me. Sorry about that. We found that most research that looked at low salience tasks found performance to decrease following sleep restriction. Sorry, you'll have to excuse me again. Sorry, I'm just recovering from a little bit of a chest infection, so if you don't mind me. So yeah, as I was saying, so these low salience tasks seem to be, or performance seemed to consistently degrade following sleep restriction. But also something interesting we found was the influence of external motivators. So a monetary reward, for example, for performing well seemed to reduce this effect. On the high salience stable tasks, most found no effect of sleep restriction on performance. And on the high salience flexible was actually a 50-50 split, with some studies that we looked at finding an effect on sleep restriction, while others didn't. So what are the takeaways from this? Well, firstly, it's important to emphasize that sleep restriction is a concern for individuals performing these critical or safety critical tasks. These elite cognitive performers, particularly if the tasks